Hello, hello. Oh god, that's really loud. Oh. Whoops. Uh, that should be better. I think that's better. Whoops. Okay. Uh, yeah, so what? Alright. Is that good? That should be better. That should be better? I hope. Oh well. Okay. Let's turn that down a bit. Well, I still want you guys to be able to hear it at least. Hold on. Turn it down there, and then over here. Nope. Nope, that's not what I wanted. Trying to get that at a good level, so it's not like a slight little bit. Yeah, that's good. Okay. Oh. Anywho. Yeah. Why is my bitrate so low? Holy crap, what is happening with that? Alright. So, pretty much just what we're going to be doing is just working on some stuff in Solidworks. Yeah. Oh my god, my eyes. Oh god. That's, why does it do that? Okay. Oh well. We'll find out if that's gonna be okay or not. Alright. It should not be doing it. Oh my god, that is creepy as heck. Okay. Hold on. I think I might need to... calibrate. One sec. Oh no. Alright, that's better. Oh no, don't know what was happening there. Okay. So. Let's do this. Yeah, so I just wanted to work on some projects. Might as well work on streaming it. So right now I've got just my, oh, you can't see the files I'm looking at. Oh, that's too bad. Okay. Now well. I have something I've been working on. I've only partially even have it printed. So right now what this is it's a little mount for the back of my monitor. It's so I can more easily... You have my laptop near me. Pretty much the goal is this sits between the base mount. This is the where it sits on the monitor, and this is where the base mount sits, because there's like a little indent for where the main stand is for the, or the what's it called? I don't know why I can't think of the name of it. Fuck. I can't. What am I saying? The base, the stand that comes with it. Basically, it's so that I can have my just use the same arm to mount my laptop above the monitor. It should be good enough. it's a pretty light laptop, so we're just gonna probably take measurements, take some measurements, and which means fuck, I need to go grab my tape measure and fuck. Of course. I started half hour later than I meant to, and I forgot to grab all my crap. But yeah, so the goal, let's make a note. We'll throw some notes up here. Notepad. Okay, so what do we want as, so it's gonna be alright. Alright, Amcam. Alright, and what was the other thing is to alright. So let's add this window into the sources. I have so many windows open, holy crap. Do kind of need that one open. Alright, yeah, so let's go to OBS. Throw this in. Why is this not? What are you doing? Come on. You got this. Notepad. Select a window. There we go. One. What is it? Is it Alt? Okay, yeah, it is Alt. Okay. Hold on. Why is this? It didn't not save my formatting. There we go. Okay, now it's my formatting. Can I not change the text of it? I want to change the font. I seriously not. That's dumb. You know what? Here, I'm just gonna give up on that. Can't do anything right now. Alright, let's just grab a note. Let's just put text. Alright. There we go. There we go. Now I can select the font. Okay. Ah, crap. What was the font I was using? What was the font I was using? No! Hold on, I have it saved on my server. I can just go check that. One sec. I should have it saved on my server. Hello? Okay, I have it wrong. I put it in the wrong place. Okay, that's on me. That font is not there. Wait. Why is my font not showing up? Hello? Am I not allowed to use custom fonts? It's dumb. Why am I not allowed to use custom fonts? Dang. Why would you do that? Wait. How can I show? No. Okay. No. There we go. Okay. It's only a slight mess. Alright. We've only got a slight mess here. Only a slight mess. That's all we need. It's a slight mess. Okay. I could probably make that. There we go. Perfect. Okay. Yeah. Okay. Perfect! Alright. Now I will be right back to go grab my tape measure. Alright. One sec. Alright. I'm back. Okay. Okie dokie. Okie dokie. Yep. Okay. So. Oh, people in Discord? Why is this not? Don't understand. Don't understand. But why? But why? But why? But why? Oh well, I don't get it. Okay. I don't know why that's not happening. Oh. Oh no, don't know. Okay. We'll go back to this. Okay, so this is just stuff that's being 3D printed. I already have this main part down. So if I don't have to reprint that, I won't. It's right now I have it as PETG. Yeah. Anyways, so yeah, this is the next piece. It's gonna be primary piece. So I just need to figure out, because my laptop's gonna be up here, and if I move my monitor around, I'm not gonna be able to see chat for a little bit. Hold on. So I have roughly, it's not flat. It's like, actually that's like exactly 4.5 inches up that I have to go. Okay. Okay, that works. 4.5 inches. Ugh. So I need to go 4.5 inches up from here. So let's edit part. Boss extrude. Sketch. Okay. 4.5 inches up. Oh. Yeah, okay. Oh, that's fine. I forgot how I had modeled that one. Okay, that's good. We're fine. So what I'm thinking I might want to do is have little pieces that come down just to help stabilize it. And what I might also want to do is split this up into like sections. That might be a little hard to do, but just to help with, like, I don't know how to describe it. Just to help with stability. Plus I might want to figure out, I might want to not have it sit in the laptop directly above, because it's a 27-inch monitor and it's a 13-inch laptop, so it's going to be a pretty big difference. So I might want to have it moved to the edge so it like lines up a little better with the edge. But okay, we're good. I think that's good. Yeah. Okay. Yeah, I don't like the way I modeled this. Okay. Okay. I am just going to get rid of the mate here. Mates. What's this one? Okay, yeah. Don't need that. Okay. So pretty much our only concern now is making sure that we size everything correctly. Okay, so edit. Now we can edit part. That's fine. Yes, I am aware that it is not. Okay, so we're just gonna delete that. Don't need that. Delete that. Don't need that. Now we'll edit sketch. Okay, yeah, I know, I understand. Understand the warnings you're giving me. Do not need them. Alright, so this is going to be this is going to be the face that mates here. So what we're going to want to do is, evaluate. So it's 4.5 inches. So we're going to make this, 2, so that's just to give us a tiny bit of room. This is something where I'm probably going to print like a really quick mock-up first. Like really bad print settings, so it's just gonna, just because it's only there to fill in and to test. But anyways, at some point I'm also going to try to get my get a camera set up at my 3D printer so that I can be doing some streaming and we can be watching the print live while it's printing. I think that'd be pretty cool. So yeah. Alright, so we're just gonna do our basic shape here. This is just the basic shape we want. Gonna put a center line. This center line is gonna be our line of symmetry. So what we're gonna do is, okay, so that's horizontal. So what we're gonna do, select all of these, then you select your center line, and it's not gonna give me, okay. Sometimes it gives you a symmetric option, but it didn't give me one then. Guess I just had too much stuff selected. But anyways, so now they're symmetric, so if I move it like this, that'll move like that, so on and so forth. Like that. Okay. Easy. Easy, easy. Alright, so basic. We don't want it to be too thin because it will be too flimsy. We also don't want it to be too thick or too wide because it'll just be useless material being used. So we'll 3/8. I think 3/8 sounds good for now. And for the distance we want it to come down. I don't know. That's actually a good question. I don't know. That's a good question. Yeah, we'll just say 1 inch for now. It's easy. And then what we're gonna do is this. So we want 4.5 inches. Actually, let's take a note of that. Ah, crap. Wait, why is it? Oh my god, why is it doing this? Oh, they're linked. Why are they linked? Why are they linked? Okay. I paste duplicate. There we go. Okay, if it didn't paste a duplicate for some reason. Okay. Now we're good. Alright. Notes. Okay. Hold on. Okay. Perfect. Okay. Good. Okie dokie. Artichoke. Okay. So now we'll probably want to... Don't show again. Okay. We'll keep it like that for now because we gotta do something else regarding the little divots here. So, originally, the plan was to have it lock in. So it just uses like dovetail type, not dovetails. I don't know what the proper term for these are, but they would just slide in. But however, with the way the VESA adapter is, I have to slide it in first and then then attach the monitor to the arm, which is a little annoying. That's not something I wanted to have to do. It's not something I really want to do. So we're just going to be mostly ignoring them. Because what we're just going to do instead is I'm going to extrude this. I believe it's an inch. Good enough. Okay, so because we made this bit a little wider, we're not gonna really be able to mate these surfaces to the edge of here, which is fine. That's perfectly fine. But there's a handy little mate called the width mate, which will let us do this. So you just select the two faces on one part, two faces on another, and it will center. You can have it centered, free dimension %, but we want it centered, so centered, perfect. Go back to standard mate, coincide it, coincident, and perfect. Yep. So even though these are filleted, we're not going to be putting a fillet in the corner here. Just I don't want to have to deal with it. Can cause, just so we don't have to worry about it at all. It would look a lot cleaner if we put the fillet there, but it's 3D printing. You can get really accurate results with 3D printing. However, if you're just doing a quick and dirty thing, you don't really need accuracy like that. So, yeah, it looks fine. Okay, so from here, we'll probably want to put this screw hole in here too. Hold on, how long is this? It's 1 inch. Oh, I haven't made it that yet. Oh, yeah, of course. Alright, mate that. We're gonna make that. There we go. Okay. So honestly, what we might just want to do is so that's 1 inch. I regret putting these fillets here. That's just gonna complicate things. That's easy to work with. Alright, so what we're gonna do is go back in here, open. Oh, nope, don't wanna. I was just trying to. Oh my god, did I? Okay. I didn't think about that. Okay. Well, we're restarting. Solidworks is fun. Alright. Edit part. Hey, I don't care. I don't care. Oh, it's It's just gonna be giving me that error. God damn it, dude. Okay, well, fingers crossed. We might just have to restart SolidWorks once we want to get that done. Okay, so this will go a lot quicker now. We know what we're doing. So we're gonna want to make a sketch, front plane. Oh, why is the origin all the way down here? Okay. What is... Okay. Hello? Hello? Alright. Don't save. We're just gonna reopen it. You're kidding me. SolidWorks, please. Please. Why are you doing this to me? Okay, there we go. We're good. Alright, so I'm gonna stop trying to make it in the window. Or in the assembly. We're just gonna make a new part. New part. Sketch front plane. Midpoint line. Already know our basic dimensions here, so we want these here. Midpoint or set point. Make that vertical. Nope. Vertical. Metric. Yeah, I can't do it if I have to do it in pairs. Alright, those are all now symmetric. Let's get these dimensions done. We made that 1 inch. We made this 4.5 or 4.502. And this was 3/8.375. And we made this 1 inch, which actually, now that I think about it, we probably want to make that bigger. God damn. God dang. God dang. Alright, we'll make that 2 inches. We'll just see what happens. Okay. Oh, actually, hold on. What's that? Got the length of the screws I had. Whoops. Okay. That's fine. We'll just have to put a... Actually, hold on. That's a good idea. Brilliant idea. Brilliant idea. Okay. So, we have... Where's my dial calipers? There they are. Okay, there's my dial caliper. The screws we have are, they're 1/4-20s and are 1.25 inches. So 1.250, which means we're gonna need them to come all the way down. However, I think I have an idea. I've got an idea around this. Whether or not it works well, I don't know. Actually, we could just make this one piece. We need a total of 4.5 inches. We're gonna have, so it's gonna be 5.5 inches at least tall, and it's gonna be at least 5.5 by 5.5 by 1. So which is not a problem for my printer. Okay, never mind. I always think my printer has a smaller build area than normal, than like others, but I keep forgetting it just how big the Ursa Mini is. Its name is deceptive. It's still a pretty big build area. Anyways, so what we'll want to do is that is centered, I believe. Yes, her distance is half an inch, so that should be good right there. What's this radius? I just made it 0.1. Okay, that was just I didn't bother changing that value. I could still make that 0.1. Okay. Anyways, so oh, this might actually be a bigger problem than I thought it was. Oh. Alright. Potentially bigger issue than I originally thought. Okay. So I don't want to go. I'm not going to get by bigger screws, so we're just going to make this work. We'll just have to make sure I have enough reach with my screwdriver. That's fine. That's fine. I've done worse to myself with designing stuff. Okay. So we're going to use Hole Wizard. I don't like using it for basic stuff I'm 3D printing, but may as well. It'll give me proper clearance. Alright. So, we're just going to do a through hole. Screw clearances. I'm going to use ANSI inch size. 1/4 inch. Or actually, no. Screw clearances. Normal. Close. We'll do close positions. And we'll just do that right there. Center. And it's through all. Actually, if we want to be. Side note, so this is just a thing regarding standards. Having that be a through all might not always be a acceptable standard, acceptable in like manufacturing. Generally, it's fine, but if you were to make a drawing and you used a hole callout on that, it will say through all. So it, depending on how complex a part could be, if there's a feature down here that you don't want touched, if it says through all, like even if you were to make, like here, actually, this is a good thing I can show you. This is a good thing I can show. Hold on. Say you had a little feature like this. Yeah, that doesn't matter size right now, so blind. Like that. Let's move it up. Yeah, so see, because this is through all, it's going all the way through. Which, if you want that in this little part here, that's good. But if you don't want that there, that's not good. Now, hey, Beans on Toast. How's it going? Yeah. But pretty much, don't want to use through all, because if you don't want it going through here, it's going to go through here. Usually you want to use up to next when it's a hole like this. Up to next will just go up until it reaches the next face, or you can go up to surface and select the surface you want it to go up to. If it's not a flat surface, that's pretty good. Or if you just want it to match like a surface that's further away. So say you were going through this bit and you wanted it to stop here, you would just click that surface. Just click that surface and it would limit it there. Yeah. So we're just gonna do up to next. And we're gonna delete that because we don't need that. Delete that, don't need that. Okay. So now's the part where we have to figure out how long. So our screws are 1.25 inches. So we will do, hold on. What is going on with my audio? Hold on. Okay. Oh. Whoops. Did not mean to do that. Hold on. Okie doke. Sorry, something came up. I had to take care of that real quick. Alright, sorry, I just had to turn that down. Okay. Sorry, I had I completely forgot that Gigi Marin's 3D debut started, so I was just putting that up and for accidentally had that so I had that on the other screen just to listen to. You should still be able to hear the music. Actually, I might need to turn that up. Hold on. There we go. Perfect. I hope that's not too loud. If it's too loud, please let me know. What? Application memory is extremely low. What the fuck are you doing? Okay, hold on. Okay, Solidworks Resource Monitor. What are you complaining about? So what are you complaining about, Solidworks? Solidworks, stop complaining. you can't see it, but I keep getting the resource monitor pop up. Turn off. Yeah, it's fine. All right. So let's do that. So all right. So this is our assembly. So I will just be overwriting our old part just because. Save to this PC. And we'll just overwrite that. Save. There we go. Perfect, perfect, perfect. Alright. Okay. Alright, so now we'll figure out how long our screws need to be. So. Okay. Nope, that's not what we want. There we go. Alright, so 0.75. So we have a 1/4 inch here, right? I believe that's like about a 1/4 inch. So that's about 1 inch there. We have 1 1/4 inch bolts, so we're gonna need at least we're gonna need a 1/4 inch up here. Probably slightly more, just so that we didn't add any clearance down there if I squish the plastic a little, which it's fine. That'll be fine. That'll be fine. Okay, so we'll just go over here, and I can either actually no, that's right. I don't need to do that. I can just make this longer. So this is gonna. We'll deal with that later. Solidworks is just being picky. 4.5 inches, I believe, is what I needed. So that is good. That is good. That is good. We just gotta figure out what I want to do here because I'd rather. Actually, don't know if my screwdriver. I don't know if my screwdriver can do that. Hold on. Oh, yeah. All right. Yeah, no, my screwdriver cannot do that. Huh. Hmm. 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 Okie dokie. I think I know. So we could make a cutout. Yeah, I think I got a solution for us. Okay, I got a solution for it. If we... Alright, yep, so that's what we're going to do. We are going to make a little cutout here. Alright, make those collinear, make that collinear here. If I can click. Can't click. I do not know how to click on things. How does one click on things? Alright, so 3/8. Yeah, that's about that. That's the same width as that, so we'll keep that at 3/8. Oh, I think I know why Solidworks is complaining. I don't need shadows. Probably part of why it's complaining, but Solidworks just isn't going to be happy no matter what. Okie doke. So I want to make this a little higher. So we're probably going to want to leave this here. What does 2 inches look like? That enough? Yeah, I think it's good. Oh, that's right. I need to change this. This needs to be... We'll make this 0.27. May as well. Okay. So that we needed to decrease that value because of the length of the screws. Okie doke. So We'd cut this, so... Oh, no. Of course I don't have the sketch selected. Right, extruded cut. We don't want to go all the way through because that will weaken it comparative to if we didn't go all the way through. So what we're going to do instead is we're only going to go 0.75, 0.625. Basically, that way we still have some rigidity here, and we have the rigidity there. So what I'm going to do is get rid of this hole. Don't really need that hole anymore. Why we don't need that hole, you will see. So we should be able to come in at an angle in order to get to the screw. So what we'll do now, a cool little thing, which will be, actually, what tool do I want to use to do that? I could use draft. I could also just put a chamfer on this edge. Nah. I'm gonna make this way too complicated. Way more complicated than it needs to be. It must be complicated. I know exactly. I'm gonna do this dumbest thing. Hold on. I want to do the dumbest thing. Okay, we're gonna put our hole for the screw back here. That should be right, I believe. Let me check. Yep. Okay. Yeah. Always double check if you're not like, because so you can't, when you're placing screw holes, you can dimension the point where it's being closed when you're putting it. I'm just put it because of how I modeled this so that it's all centered on the origin. It's perfectly fine to just put it on the origin. Now, okay. I just realized I never had dinner. Anyways, why am I still? Is it? Yeah. Okay. I should not have been able to see that. This is gonna be. I know. This is gonna look so dumb what I'm about to do. Okay. We're gonna put a sketch here. Oh, actually. All right. This is gonna be. This is gonna about to be so dumb. Hold on. Okay. Okay. I regret having this thought process, but impulsive thoughts, I've got to do it. Got to follow the impulsive thoughts. Okay. We can exit sketch, because we're gonna make more sketches. Alright, just for the head of... So the head of the bolt is... like 3/16, so we'll just make that a 1/4 inch, so... We're gonna offset a plane here, 1/4 inch. And what we're gonna do is we're gonna make another sketch on this plane. And we're gonna do convert entities, and what that will do is so there's two things you can do. Is there's project silhouette. Oh yeah, I forgot they added silhouette, but convert entities, it will pretty much take whatever that circle looks like and put it on the plane. However, it's like perspective driven, so like if you did this, it would just appear as a line. If you were putting it on a plane like this first, that was like parallel to this face. So, yep. So we'll just exit sketch. All right. Now what we're gonna do is we're gonna make a sketch up here. This is gonna look so dumb, man. What am I doing with my life? Yes, yes, SolidWorks, I know. What size did I make those? 0.5. Why am I doing this? Why am I doing this? I'll make that ½ inch there. Can and what we'll do is we'll add a center line down from there, and perfect. Alright, so that's fully mated. And I regret doing this, man. Why am I doing this? Why am I doing this? Why am I doing this? Oh. Oop. Oops. Oops. Okay. I know what we're... Alright, I know what I'm gonna do. Hold on. I know what I'm gonna do. Okay, I know how to fix this. 0.5. Alright, 0.5, we're gonna make this... No, I'm not gonna make a construction. We're gonna take the line tool, come up tangent to the edges, and we're gonna take trim, and we're gonna trim. Now we're gonna exit sketch, and... This is so dumb. Why am I doing this? What am I doing with my life? What am I doing with my life? I just realized how bad this is gonna look. Okay. Lofted cut. Let's go. Let's get it started. Oh. Oh. Yeah, it's doing that stupid thing. Okay. Yeah, so that's one problem if you're going from a circle to, or going to a circle from a thing with curves. I don't know how I want to do that. I regret my decision. Alright, I got it. Hold on. I can fix this. Do the same thing to this plane. Oh, nope. Wrong sketch. We'll do the same thing to this sketch. This is so dumb. Why am I doing this? Alright, trim. Alright. This looks... What am I doing, man? What am I doing with my life? What have I done to get here? Oh, it's not gonna like that. Oh. Okay. We'll just do that. And then we'll trim out that area. I don't know, I made this so much more complicated because I wanted to do something stupid. It's fine. I can't do this. I'm not allowed to do stupid stuff like this at work, so it's fine. It's fine. Okay. I see. Okay. Want it coincident on that, so we'll do horizontal. I make this tangent? Yep, perfect. Perfect! Perfect! Oh, no, that's not good. Hmm. 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 That's not what I want. Hmm. Hmm. Nah, we'll do this differently. Different. Hmm. How else can I do this stupidly? Hmm. I know. Yeah, I'll just do a 3D sketch. Hold on. Yeah, I'm taking the lazy way. Spline. There. There. That. Okay. What am I doing, man? Okay. God damn it, dude. Swept cut. Alright. Oh, nope. That's way. Okay. So we just make it circular profile. That way it'll. Alright. Oh, no. No, that's not what I want. Alright. I give up on doing it stupidly. It's just wasting time. Alright. Now, the way I should have done it from the start was just chamfer this edge down, but I just wanted to do it in a dumb way. So, well, let's do it. What we're going to do is we're just going to cut out a little bit here. Alright, we'll make that 1 inch. 1 inch. No, 1 inch. That 1 inch. 1 inch. And we'll make this 1/2 inch. No, 1 inch. Got it. Alright, so we're just going to do up to surface. Yes, this is a good example of using up to surface. We want it to be flush with this surface, so just select the surface, and we got that little cutout. Now what we're going to do is, the reason I made this so differently, like, because I don't think we need that much of a cutout there, but what we're going to do is we're going to use chamfer, go there, and what we're going to do is distance. It's going to be asymmetric, so we're going to want to make this 1 inch. Alright, so that's the wrong value we want, so 0.625, I believe. And then this one we want 1 inch. Yep, so right there. So we could have easily just done a mid-plane and made this profile, but using the chamfer makes it a little easier to change that value when we want it to. Now, do that. There's literally no reason for us to have that chamfer like that, but who cares? We already did it. No point in changing it. So what we're going to want to do now, I'm just going to chamfer these just to make them a little nicer. A It'll look a little nicer. Oh, that one doesn't work. That won't. This. Like that. Perfect. Perfect. Oh, that looks a little weird there. Yeah, no, we'll just go back and get rid of that. We'll just do chamfer across the entire thing. Distance to distance, so we're gonna wanna swap those. So this is gonna be the 1 inch. This is gonna be 0.625. Okay. People on. Alright, so I'm gonna go blind cut. Alright, good. We got that there, that there, that there. Fill it that a little. Just make it look nice. Nope, we'll make that wrong way. There we go. That's better. We'll probably also want to add like little part there. Alright, so let's throw this in here. Insert component. There we go. Okay. Ba-ba-ba-da-da. That's good. Maybe I think I should. I think I know how to change. I think I need to do that. Hold on. I think I made this cutout a little. This cutout's a little too deep. I don't like. Nah, no. We'll just. We're gonna scrap that. Hold on. I think. Yeah, so what we're gonna do, we're gonna get rid of the collinear mates there. We're going to make that like that. We're gonna change this. We're gonna make this just 1 inch. Um, no! Stop giving me that pop-up warning. I know Solidworks. I understand. Alright, so this is what I should have done from the beginning. To surface, and we're going to go up here. This, I just realized we're going to need to make this cutout bigger. Reason being, our screw size. That's 1.7. Actually, yeah, that's big enough to get our screw in there. Now we're just going to chamfer this down. Like that. Good enough. Okay. That's probably what I should have done from the beginning. Now we'll add the old wizard. Old wizard. I'm a whole wizard. Positions right there. And right on the origin. Good. I'd say that's a good change. I like that. Only challenge is going to be... Hmm. I don't know. Okay. Alright, now what we're going to want to do is I'm going to save this. We're saving this. And we're going to go and edit it in here because we want to grab this profile. Why is it not pulling up? Edit component, there we go. So we're going to make a new sketch. We're going to grab these profiles. We're probably going to do the same 2000s. I think that should be. I'm gonna increase this offset a little bit. Sorry, I have something else on the other screen. Key probably. Let's keep going here. Yeah, let's do that. We'll just mirror this for now. It's probably gonna look weird, but we'll do it this way. We'll do 0.09. That's fine. It'll look fine. Okie dokie. Okay, so that's gonna bring it up to about level with the monitor. So what we're gonna want to do now is figure out just how we want to do this. I don't have like a protractor or anything to test that. Because basically what's gonna happen, let's alright, so basically my laptop's gonna sit like this. So we're gonna wanna, because I could have it folded up so it's like flat, but just in case it's doing anything like heavier, I don't want it to be starved for air and overheat. So we're just gonna make sure there's a little more space for airflow. I'm just trying to think of what I can do. Alright, I'll just... Hold on. Alright. So now I got the laptop right here. Figure out, we want it like that. Okay, let's figure out. Okay, let's get this measurement. Alright, so it's roughly gonna be 8 3/4 about. It's a little more than that, but I'll just say 8 3/4. We'll just say 8.8. Alright, and we got 8.625 on the screen. .625. .75. Okay. Okay, so let's measure this. That is what? Oh. That's why it's so weird. Okay. I was like, wait. Right, so I want this to be vertical. Hmm. Alright, we'll just do it this way. And so there's nothing at the bottom. Okay, yeah, so we should just be able, good to get the thickness of it. Hmm. Alright, so I'm just getting a basic idea of what I want. Um, those we want to be collinear. Send those equal. And I believe this value will need to be 0.43. I'll just double check that real quick. I could get away with 0.427 probably. And this angle, let's make it 75 degrees. Yeah. Well, yeah, I see what we can do. Okay, so we'll get rid of this. So if we get rid of that, we can drag this like this. So what we'll do is make this construction. Just don't want to lose the relations it has. So we'll just do this. We'll come down. So we'll make this flat. So this is vertical, so we're going to make that collinear with this. So we're still got some movement here. So going to need to add a little thing there. How long is that? A quarter? Hold on. Oh, I know. This would be a good spot to put it right there. Okay. Key. And we'll do... Alright, make that tangent. We'll put that on there. So we'll want to have a little... We'll just do it this way. We'll add a fillet and we'll make them both all... Oh, hold on. It's 5.5. Oh, that's way too. Okay. That should be good, honestly. I'm just worried. Okay, that's 1 inch. That's 6.5 inches. That's good there. Yeah, I was just concerned because. What? I'll make that a separate part. Might as well. Might as well add more complexity to this thing. Yeah, know what? We'll make that a separate part. Okay. Uh, how do I want to do that? So I'll need 1 screw for that. So I have 1 more. I'd actually do 2 more. Okay. Oh, perfect. That's actually perfect. Hold on. Perfect, perfect, perfect. Alright, so what we'll do. .25. Actually, no, because this will be the part that's holding the laptop. It will be thicker than this. It's just this is the point where it's gonna be help align it. 1 inch. So we'll do that. Okay, so now we got this. Gonna do this, center rectangle. All right. All right. So let's check this. I want to check this. 5.25. 0.75. So we'll want 0.75 thickness here as well. Oh, did I do that? Whoops. Put that on the wrong plane, didn't I? Yeah, right plane. Uh, 0.7. That's fine. Yeah. All right, so we're gonna save this. This is gonna be 003. Now we'll insert this component. Okay. feels really weird doing it like this, but... So what we'll do is we'll add like little supports that come down just to help brace it against. It should honestly be fine the way it is, but just for peace of mind. Because my laptop's going to be on there, so... actually, hold on. Yep, so we'll do this. Hold on, no. So we're going to want to go 45 degrees there. Why did I... Just want to coincident. Oh, we'll do 0.25 there, or 0.25, 0.252. Just a little bit. Actually, we'll go even smaller. Do I want to go all the way? Oh, yeah, screw it. We'll make it go all the way. That's good. And we'll change this. Don't want that. I want that to be 45 degrees. Reason being, it'll just make it easier to print. So I could print it with this side facing down, and it'll be fine. So, we're good. That's good. Now, do I have the orientation on here correct? Did, yeah. Woohoo! Okay. So... This is 1 inch, so... Key, that's good. It's very bulky. I think I can take some material out of this. So that should be like right at the top of the monitor there. Okay, I'm gonna be more focused now. Hmm. Alright, 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 alright. So... How do I want to do this? I don't think I need that to be 2 inches, so we'll make that 1 inch. Oh, I see. Okay. I probably will need to be that much then. Hold on. Yeah. Okay, so that's like the bare minimum it can be. I can't have... Well, that's the bare minimum. Let's get rid of that. So we'll start building the part that actually holds the laptop up here. So the laptop is... Actually, let's put this in my notes. That there. And... Let's do... I really wish I did want to make like a quick mock-up of my monitor so you can actually see like what it looks like, but I didn't get around to it. So it's gonna need to be angled this way. Let's try it this way. Let's do this. So this is definitely gonna need supports, but that's fine. That's easy to take care of. I don't want that to be horizontal. I want it to be perpendicular. And these are gonna be parallel. This, make that 1/4 inch. That should be good. How high? Actually, let's do this first. 75. 1 inch there. Just actually do one in, like, just do 2 inches. It's my laptop, so I want to be more safe with it. And I just realized I messed up and forgot a step. Okay. Just don't want that to be there. Let's make this come up like that. We're gonna want our primary supports. And the distance between these needs to be 0.43. Did I read that right? Hold on. I'm checking that again. Yeah, 0.43. Okay. Doubted myself. 0.43, so Hmm. Oh, whoa. Hold on. What did I do there? Let's make that 2 inches. We'll just stick with that. And that will want to be collinear. Just for neatness. This could be a pain to print. Oh my god. Oh, no. I know what I can do. Hold on. So what we'll do is just... have that. And we will be able to get rid of that. So what we'll do is make a line from here to here, make it perpendicular, and this will be 0.43. Perfect. That'll be a hell of a lot easier to print. So it'll be 2-piece. Oh, I have open. No, closed it. Hold on. Do that. I like it. Save that. And pop back over here. I'll make a 4th piece. So what we're gonna do, get rid of that. And what we'll do is make this cut out a little bigger. And we'll just have a second slice, another slice. Okie dokie. Alright, so let's over here. So now that's like that. Now we'll have a slice. We'll make a slice. What the slice will do is pretty much just put a layer there to add as the inner. So it'll make sense. It will make sense. Should make sense. Yeah, should. Okay. So that's 0.25 there. I'm gonna make this. This is 0.5, so I'm gonna actually take another 1/8 of an inch out of that part. So 0.625. So we know 0.625 plus 0.25 is 0.5. And that'll give us roughly 3/8. Hello? 3/8. Yep. Okay, perfect. Perfect, perfect, perfect. That's what I need. Okay. So basically it's just going to be another slice that comes up and has the angle. So easy. Easy peasy. And we will, yeah, new part. New part. This will be 004. Save all. Rebuild and save. And oh no, wrong plane. Right plane. We'll just do it like this. So it'll come up like that. So these are equal. All right. So that is going to be 1 inch. 1 inch. I'll put just for hecks and giggles. Just for the heck of it. Oh, no. Wrong number. Alright, so what's it? Angle. Okay. Angle's easy. 75 degrees. Yeah. Now, if I... Honestly, what I should do is make it a global variable. And in the assembly, and I could possibly get it to read the variable from the assembly and just change it in the assembly, but I don't feel like it. That would take... I don't feel like doing that right now. I'm all for adding complexity, but that's too much. That's too much for me. Even though I do kind of like working with variables. Is it 5.25? Alright, because we wanted this one to be thicker because it's supporting more weight. There. Advanced width. And then we could do that. Perfect. Sweet. Okay, so evaluate, measure from here to here, 1.49 inches. So that's going to be roughly 1.5 because I think that was overlapping a little. So let's actually do that right now. .5. Perfect. Okay. And what we'll do from here, put the holes through. So, Are these are collinear, these are on the same plane. Okay, we can go from there. What we'll do is 4 inches distance. Let's do it on this one. So we'll start on this side of this one. Do. Just gonna do this. And 0.5. What does 4 inches look like? 4 inches? Yeah, that's good. That's good. Make that for construction. And what we'll do is hole wizard. Oh my god, stop. Oh my god. Not what I want. Come on. Because I put a point there. Okay. Now we'll do hole wizard. There. 4 inches, and then we'll put a little X here for the bolt. For the nut. And what size are these? These are 0.4 0.44 work. Yep. Oh, 0.5 or 0.45. 0.445. 445. We'll do 0.445. And how do you... Yeah, 0.25. So I technically don't even need to put the indent there for the screws. That's good. I like that. I mean, then if I want to put washers on there, I don't need washers, but I think I'll be good. I think I'll be good to just yep, 1.25. Actually, no, I do need it. Okay, never mind. Whoops. Do need to put the holes there for the screws. Okay. Let's do this one next. Oh, does it just automatic? Okay, no, it's good. 4. Oh, that's 5. That's not 4. And hole wizard. Alright, so far so good. So far so good. I don't like that is gonna be so thin though. That might just be something I have to live with. Yeah, I think I'll just have to live with that. Alright. So this is the one where I need to be careful because I don't remember the tolerances I used. So we're going to convert that edge. I'm not sure if it is... Oh, it's collinear. Okay. That's good. I mean... Damn it. God damn it. Dang it. God dang it. God dang it. God dang it. God dang it. Forgot that the origin was there. Forgot I did a center rectangle for that one. I was thinking of how I did the slab. Yep, okay, that's good. Alright, good to do a hole wizard. We're gonna do a counterbore. I'm just gonna do counterbore. Not a hex bolt. Alright, I don't need it that deep. No 125, that's good enough. Alright, let's save that. Oh. Go much deeper with that. What am I doing? Oh, it's because it... I think I... Okay. I know why it's doing that. Okay. And what I'll do actually is make that a little less deep just so it the screw doesn't go poke all the way through. That's going to be 0.2, 0.19. Perfect. Perfect, perfect. Sweet. Yep, only thing I want to do is fillet that. Fillet the edges that are going to be against the computer. So this one. 125 is good. Honestly, doesn't really matter. You could just leave it as the default, but all right. Save all. That looks good. Honestly thinking I might want to add like a little support thing there. Yeah, know what? Might as well. 375. Yeah, that looks good. I think that looks good. Doke. And just for fitting reasons, what we're going to do is put a small chamfer, so in this case 5 thou, here and here. Yeah. 0.01 works. Alright, how did that affect? Yep, so we're just adding that. So just in case there's any impurities in those, or any imperfections in those corners, it'll still be fine to go together. And we'll do the same thing right here. 0.01. Just because those are inner corners. Yeah. Double check that just before I finalize it. Okay. Yeah, no, okay, good thing I checked. Actually, we can get away with that. Yeah, we can get away with that. Good. We can get away with that. Okay, so I think we're good. I'm just trying to think if there's anything else I could do just to save time. Honestly, not really. I'm kind of happy with it. I don't have my stuff set up to be able to like do like Prusa Slicer and such yet, but I'm gonna try to set up Octoprint. That way I can just start a print from here and just worry about that later. But actually, does Prusa Mini have? I don't know. I forget. So it does have Wi-Fi. Oh, it does have RJ45. What? There's no picture of the... There's no picture of it with the RJ45 though. That's not RJ45, is it? That's the power. No, that is okay. No, that is the Ethernet. Okay. I thought that was the power at first. No, that's okay. Yeah. No. Rolex branded. Yeah, I guess it is the Ethernet. Oh, that surprised me. Huh. Interesting. Okay. Fine with me. But I'll be right back. I think we're good on that. So, we will do. I will be right back. I'm just going to quickly use the restroom. So let's put in a note. Alright. Let's get another note on here. BRB. BRB. Perfect. Alright, I'll be right back. I'm back. Okay. Ah. Oh. Okie dokie. I'll hide that. Okay, perfect. I got a beer. Beer and a glass. I still haven't made myself have dinner. I still have not had dinner. Hmm. Okay. I'm honestly surprised about that though. Hold on. Okay. So. Good. Good. I like it. I like it. Alright, so okay, we're good to close out on that. Let's save these as STLs real quick. Well, not STLs. I've been trying to move away from using STLs. I've been trying to do 3MF. I don't really have a reason for doing that. It's just I've had some issues with STL files. Oh, hold on. There we go. Don't know why it's not letting me do that. And that one, save as. MF. Right, perfect. Now if I was using PDM, I would check in them. It would already be checked in and checked out. But I don't think Solidworks is ever gonna give what's it called? PDM to their for Maker edition. But if I'd be willing to do a little work with that if I ever got big enough, I'd definitely be willing to do some stuff like that. So, anyways, Alright, so now this next project, it's gonna be a little bit more difficult. It's much. So what I'm going to do is let's do this. Can I? Is there a strike through for this? No. Okay. There's no strike through. Is there? No. Darn. Oh, there we go. Strikeout. Oh, I can't. Darn. Alright. Well, we'll just do this the other way. So, let me grab this heavy thing. So, basically, I have a 2U server that I wanted to make a new front panel for. Reason being, I want to have it set up to be able to run, like, I do have a NAS. It's a different case, but this extra 2U server I have in here, right here, it can support an ATX board, and I can put a more powerful CPU in it. However, it doesn't really get hot, but I'm just worried that it will. So I'll see if I can pull up a picture of the original. This will be right there. Yes. Okay. Do they have like a front picture of the front profile, or that's something? Okay, that doesn't really help a lot. Let's do it this way. So let's see, can I just paste this? Oh, okay. Image. Let's give that there. Documents. Yeah, so this is the server. As you can see, it's pretty restrictive airflow. Like, under each ridge there's a small opening, but it only goes across like 2/3 of it. So it's very, very like restrictive. So I was just gonna make a custom front for this. It should be fine. So the handles on the sides, they don't screw into the front panel. The front panel is like its own little fake overlay. The only thing I have to watch out for is making sure that they're gonna fit properly. So yeah. So we're gonna start by just making just making a basic shape of that. Oh. Oop. We'll move that over here. That works. Okay. So, the edge of it's sharp. I didn't cut my leg, luckily, so I didn't cut myself, so we're good. Let's see. So what we're gonna want to do, I'm gonna make the profile of it. I should be able to get away with just doing this and using thin feature. So, because it's a piece of metal. So let's grab. It is 0.059, so let's check what that is. Metric. Metal thickness. So let's look at this chart. Thickness. So it's probably gonna be 16 gauge, it looks like. Let's stainless, hold on. This is gonna be probably standard. I doubt this is stainless. was 0.05 something. 0.05. Yeah, it's a 16 gauge, so it's going to be roughly 1.5 millimeters. Okay. Yeah, that's good. That's fine. It's easy. Alright, so the top here is... Let's go there. It's just, oh, it's 0.8. .8 inches to millimeters, 20 millimeters. And the bottom, probably the same, but let's check just if, yeah, it's the same. So these are going to be equal. Excuse me. Okay. And the front. Overall of this part here is 1.49 inches, so that's how thick is, oh, hold on. Wait. Wait, what? Hold on. Am I an idiot? Yeah, I guess I said 1.49 instead of 3.49. Okay. Whoops. Alright, so it's 3 point. Standard rack size is 3.5 inches. Alright, so what we can do from here is we're going to use thin feature and use thin feature. What it does is will extrude a certain thickness along a distance. So as you can see, it's extruding this way off. If I flip that direction, which is what we want, it will go inwards. And I believe it was 0.5, 16 gauge, so 1.5 millimeters. So we'll change this to 0.5 millimeters. And we'll measure the length of it. So how long does this need to be? Oh wow, that's actually like right on with a... That's 10/16, 11/16. Right? Yeah. 16 and 11/16. Nice. Nice. So 16.6875, right? Yeah, 688. We'll do even just to, and we'll do midpoint. Right. So this is pretty much the front cover here. Front cover on that thing. And what we're going to do is now we're just going to measure out where these holes need to be. So let's actually save this right now. Save the Solidworks. So this case can take a horizontal GPU, so we're going to say 2U GPU case. Oh. 2U GPU chassis. reference to you original. It doesn't really matter what we name it because we're not going to be really paying much attention to it. So, alright, so sketch on the bottom. What we're going to do is we're going to put our holes. Yeah, I should use Hole Wizard for it, but I don't really care about the size of the holes. Right now, at least. What I care more about is making sure that it's able to be used. Or it's just accurate to the positioning. So we have 1, 2, 3, 4. We have 4 screws that attach to the chassis, and we have 2 that attach the front I/O. So they're not spaced like that, but they're roughly in the right location. So what we're gonna do is we're just gonna add center lines between all of them, just to be sure that they all will stay straight. They're all equal, so. Alright, so we're starting on the left. So from this edge, it is I really wish I had a way to measure metric. 1 7/16. So 7/16, so 1.4375. 2 millimeters, 36. Is it slightly under? It is. So it's probably 35. Huh. I really should have taken this thing off. You know what? I'm gonna do that now. Hold on. Let's take this apart. So, because it's just been like bare edges of sheet metal just laying on my legs right now, so it's kind of uncomfortable. Just bare metal, bare 1.5 millimeter sheet metal, 16 gauge sheet metal on my thighs. The shorts are fairly short. Plenty of padding, it's just not the most comfy. What's the point of doing anything if you're not comfy, right? I forgot how much movement this lets me do. Got it. I really should have enabled lip sync when I'm not, when it's not tracking, because that'd be funny to have it me talking to with the metal on metal action that's happening right now. Okay, dog. Got this. Why is that not gonna... Hold on. Not cross-threaded, is it? No, it's not. Okay. Ew. Don't like cross. Yep, okay. Now we can take out the... do I need to take out the front I/O to this? Yeah, I do. God damn it. I didn't want to have to do that. So we'll take the front I/O off. That's probably going to be the more difficult part of this. Though I can put the front I/O in a better spot because it's not in the greatest of spots right now. Because it's like a little sunken in, and it doesn't. It's a cheap chassis, so it doesn't fit right. Get my other hand on that. Because it is stuck. Well, just pull it. Eh, got it. Okay. Now we got this one. Now we can start actually taking it off the case. Ba, ba, ba. Another thing I have to watch out for is this case gets very flimsy if you don't have all the sides on. And that's kind of standard for PC cases, but this does add a lot of rigidity to it. Actually, no, it's the there's a little inner piece that oops. There's a little inner piece that sits a little further in that the fans mount to that actually give it more structural rigidity. Alright. Got that off. But yeah, so pretty much the way this was made, it's just punched like where it's extruded, and then looks like they did they do that? The only way I could see this being made is extruding it. Looks like they must have made a lot of these things. Yeah, there's a little manufacturing defect right there. That's how, yeah. Ooh, what were these for? That they made an extrusion mold for it. Huh? I doubt they sold that many of those cases. You can't even buy this case anymore. I mean, probably for good reason. The airflow sucks in it, but were enough people buying these? How were enough people buying these to justify the manufacturing? I can't tell if they... No, that's not a machining pass, I don't think. Looks now... Okay, so... Looks like they just came in with like a grinder and... like a CNC grinder or something, and just... Because that's not machined, that's like cut. You can tell it was probably done with a grinder by the... Or it was just... You know what? I think I should just stop wondering. Me wondering how the hell they made this goddamn thing is just gonna end poorly for everybody. Alright, let's get back to it. So... I'll be more prepared next time. I'll make sure I have like photos of this. Hi Dev, how are you? I'm doing alright. Thanks for coming. Thanks for stopping by. So this is definitely going to be 35 millimeters. That first hole is probably going to be 35 millimeters. And I'm just working on a small project. So I have a 2U server chassis right here. I just finished this above my computer mount, so just moving on to figuring out how I was gonna make a custom front panel for this. Basically airflow is really bad on it, so I wanted to make something with better airflow. And right now I took this little front piece off and I'm measuring it. I might just measure it, get that all set, and I'm probably gonna be done for the night. It's currently 10 and I am tired and have not eaten. Any pronouns work for me. Doesn't really bother me, whatever people use. It's never bothered me, so it's never gonna start bothering me. Any y'all. so that's 35 millimeters. Alright, and then to this one. Whoops. You just stick with they, them. They, them's usually easier. But, like, if someone uses other pronouns, I don't make a big deal out of it. As long as someone's not, like, being intentionally, like, a jerk. It's like, who cares? Sorry if that was loud, by the way. Right, roughly 5.75 inches, little under. So that's going to be 5.75. What is that in millimeters? I don't have my calculator, so I have to use Google. 146. Yes and no. Like, I don't really do it that often, but I do. Like, I built my own computer. I built my sister's computer. I've helped friends build computers, so I do know my way around to putting a computer together. It's gonna be 140 millimeters, I believe. I think that's 140. So 5.5 roughly. No, let's just go from the end. I know I was just trying to measure it from the center to center, but I think I should just go from the end. So that is going to be just under 7 inches, which is 177.8. That is such a weird number. What the hell was it supposed to be? Is it supposed to be 178? Yeah, I think it's 178. Huh. Sometimes these manufacturing, it's just wondering, like, what the heck were they doing? Like, were their tolerances, did they have, oh, that's 178 inches. Sometimes it's curious what the hell their tolerances are. Alright, so let's get that measurement out of the way. So from the edge, it is just under 1/2 inch. So that's going to be in millimeters. Yeah, so I made it in Vroid Studio. The eyes I made myself. I love coffee and lattes and espresso, so I figured might as well use like latte art as inspiration for my eyes. But the other stuff is either stuff, so like my hair is just standard in Vroid Studio, and the clothes I got on Booth. I believe the shirt I had to pay for, but like the apron, it was like really cheap, but the apron was free for use. I guess that's 10 millimeters. What's it from the other direction? What the hell is that measurement? What the heck? What the heck was the manufacturing on this thing? 10 millimeters. Okay, that's easier to just go from that side. 10 millimeters. Okay. let's get these measurements now. I keep hitting this with metal. Whoops. Alright, so this first one on the other end is going to be 1 and 6/8. No. Just under 1 and 7/8. Or no, not even 1 and 7/8, just under 7/8. So 875, 0.875. So 22 millimeters is 0.875, so that's going to be probably 20. Yeah, it looks like 20. That's going to be 20 millimeters from here to here. Sizing, like, what was this manufacturing, man? This looks so bad. How did they do this poorly with it? I don't understand. Alright, so this is now going to be pretty much like 5 and 1/16, so 5.065. Did I read that right? Yeah, I did. Hold on. Yeah, I did. Okay. It's gonna be 120. 130 millimeters? No, that's like 129. What the heck? Yeah, no, it's so this was a pretty cheap case so when I bought it, so like quality control was definitely not great with it. Basically, like, it's really not clear how close their tolerances needed to be. Tolerance is basically how much a number can, or how much a distance or measurement can differ while still being acceptable. Wait, no, 130 millimeters. So basically, this number is 5.12 inches. The tolerance would be, like, it can go anywhere from, like, plus or minus 0.0. If it's set, say the tolerance was plus or minus 0.02, this could be anywhere from 0.514 to 0.510. Basic, and obviously tolerances are never going to be that big, just because that's a fairly big difference, especially if it's something that requires assembly. But especially when it's something that requires assembly, you need all the tolerances to, like, line up and be generally accurate, so it's able to be put together. Nowadays, manufacturing is fairly consistent. Automation has taken a lot of human error, at least, out of it, and made, like, placement of holes and such much more consistent. So even if they're all off a little bit, they're usually all off by the same amount. Yeah, tolerance is basically just like the range that's something that something can be. So I'll see if actually here I can pull up here. I'll actually pull up a good chart about that. So the best way to describe this is through let's see. No, that's not really what I want. Hold on. Alright. So this is a fairly... I actually need this chart. Okay, so I found a little, just grabbed a little chart. So let me throw this on OBS. So this is a basic chart that shows like these are what's called GD&T, which is geometric dimensioning and tolerances. Basically, when you're manufacturing, you have to control when you're making something. So whether it's on a CNC machine, it's on like a laser cutter or something, stuff generally needs to follow a certain like range of stuff. So basically different features. So say this hole, I have this hole here. The hole would have a circularity tolerance. If it matters, it will have a circularity tolerance. It'll have a position tolerance. If there's a hole on the other side that it needs to line up with, it'll have concentricity. Basically, all of these determine how accurate a part needs to be. Let's see, how else can I? Yeah, straightness, obviously. So like if you have a line, or have an edge on something, if it needs to be a certain straight. If you have a surface, it needs to be a certain flatness. Surface profile, line profile, those are the same thing, like pretty much the same thing. But if you have like a custom, much more complex thing, angularity. So if something needs to be like 90 degrees, it has to be like within that certain range. But tolerances basically matter when it comes to nope, didn't mean to move that. Tolerances matter when it comes to manufacturing because stuff needs to go together, and if it doesn't fit right, it can't go together. And fun thing with tolerances is the more precise something needs to be, the more exponentially expensive it is. But yeah, right now I'm in school for engineering technology. I currently have a certificate in CAD design and computer-aided drafting, so that includes stuff like GD&T, CAD design, which is what I'm doing here, and I am also a certified Solidworks associate. So what that means is pretty much I have certification from the company that makes Solidworks that, hey, I know how to use the software. My day job, I work as a CAD designer, so normally I don't like doing this on weekdays. That's why I'm doing this on a weekend. But yeah, if people are interested in this, I'm definitely willing to do it whenever. But yeah, I enjoy being hands-on with stuff. Enjoy trying to be creative, and yeah. Sometimes I'm not great at when it comes to being creative, so. So this hole is actually, I should just measure the screw. What size is the screw? The screw is 0.13. Yeah, thank you, Dev. So that is 0.133 inches, so that's M3, is it? I believe that's M3. No. Well, I mean, so right now, I pretty much don't really do like a lot of my own design, like at work. What I mostly do is assisting engineers with, like, if they need, hey, I need this part made real quick, I'll help with that. I'll pretty much make sure the machine shops can actually make the parts the engineers need. I also make like instructions for assembly of machinery. I definitely want to be like the one doing most of the designing, but still working out how I want to do that. I think what I probably want to do more is more along like application engineering, which is knowing pretty much like the ins and outs of the software, because I do a lot of like back end macro stuff and yeah, and working with like the networking and such. But I just don't like doing it during the week. It's just because I pretty much spend all day in this, in not this like month. My work has it. I have my own like work laptop and such, but it's just because I pretty much am in this software for 8 hours, so I just don't want to see it again. If I don't have like something I really want to work on and like of my own, I sometimes just need a break. But like honestly, if I'm in a good spot with the projects I'm working on, I'll probably even hop on and do some stuff with it. So, all right, so it looks like those screws. Oh no, you're good. You're good. You're good. No worries there, buddy. No worries there. Thank you so much for stopping by. Like, I like talking about this stuff, so I'm never gonna complain about that. All right, so those are the holes for the where it mounts to the frame. So let's grab the I/O holes. The I/O holes are a little further, a little closer. They're a little closer to the edge here. Little I/O brackets right here. It says chaos on top, and it says, I believe it's powered by coffee. I actually forgot. Hold on. It's chaos and coffee. Okay. Chaos and coffee. Yeah. I had to check that real quick. I had a texture saved on my... I had it saved on my desktop, so I had to check that. Yep. Chaos and coffee. 1.55, just over 1.55 right there for that spacing. So this spacing, what got me into streaming? Let's see. Honestly, just being able to like possibly entertain others. Like, I know I don't really get many viewers, but like, hey, if I'm doing something for somebody, like, yeah, might as well. Also, honestly, kind of inspired by basically like a lot of the charity work a lot of VTubers do. Like, and I want to definitely at some point do charity stuff, so. And since I don't really like, I don't know how to explain this. Since I don't really like showing my face, and doing this is not nicer. My Oshi. Oh, that's actually a tough one. So, the first like VTuber I ever knew was Iron Mouse, but it's kinda. But I don't really watch her anymore. Definitely watch her and Sea Dog though. Jeez, who is my Oshi? Probably have to say, Huh. This is I never really put much thought into it. Hold on. I'd probably have to say, Nanashi Mume. She. Oh yeah, you did. Yeah, you spelt it right. Nanashi Mume was definitely Mayoshi. She graduated not too long ago, but she was a VTuber for Hololive EN. And honestly, there's something like with her personality and like her behavior and her like what's it called? Not really behavior, but like vibes that kind of like felt similar to me. And it was just like, oh, well, someone's able to do it, why can't I? Sort of thing. Yeah. Yep. Alright, dang, I closed what I had. Whoops. I thought I had already written this down. 1.55, around that. So 1.55 inches, so that's 40? Really? That's 40? I guess so. Okay, that's 40 millimeters. Alright, and I'm gonna get rid of that, and we're gonna make that equal to this. And these will be equal. Alright, so now we just gotta figure out the positioning. Alright, so the positioning, it's gonna be a little closer to that bottom edge. And the other holes, I think it's roughly 2 millimeters closer. So 8 millimeters in inches. Yeah, 8 millimeters. Perfect. I'm trying to not bang around this piece of metal. Yeah, I was kind of scrambling to get stuff ready because some of my stuff wasn't working properly when I tried to start it up. So this is gonna be roughly 1.2 inches from the right edge there. All right, 1.2 inches, so that's gonna be, is it over or under that number? Slightly under, so I'm gonna say 30 millimeters. I mean, this doesn't actually really matter if I get this number accurate, because this is just reference, so I know what I can compare the new one I'm making to. Extruded cut up to next. Yep, okay. There we go. That looks good. Do I want to add this profile? Yeah, might as well. May as well. Okay. Let's... Nope. Dang it. That's not what I wanted to do. Yeah, basically, well, I meant to click on the surface, not the corner, and when I clicked on the corner, it did something I didn't want it to do. Alright, so Holes are on the bottom there. Let's do this. So now I'm just adding, there's like a pattern on the front of this that I'm kind of curious about, just to see if I can figure out what it is. This part is definitely thicker than it's definitely thicker than this part, so what we're gonna want to do, this is like, oh nope, yeah, so it is a little thicker there. Let's do, what do I want to do this? Yeah, we'll just add this here. Okay. Grab our piece of metal again. Grab a piece of metal again. Piece of metal. Piece of metal. Piece of metal. Alright, so this little bump here goes up to, let's try to get this measurement. This value doesn't really matter at all, so we're just gonna, no, I mean, kind of it does. Yeah, I'll be a little more accurate with it. At least the overall size, doesn't really matter. So that is 0.178 inches. Thank you for the follow, Dev. Thank you so much for stopping by. So that is 4.5 millimeters. Thank you, thank you, thank you. All right, what is this measurement? No. Oh, it's about the same. Oh. Okay. 4.5 millimeters. That's easy. Easy. Okay. So now's the weird part. So I am going to do the first little piece of the pattern, and then we're just gonna pattern it. We're just gonna copy it down. But I don't have to keep doing that over and over. So we'll get the basic shape, or the basic profile of it first, so. Great, and then it comes up that. Welcome, welcome, Blub. Hello, hello. Working solid or solidly working? Well, it's Solidworks, so who knows? Alright, so this first spacing here is going to be... I keep knocking stuff over, god damn it. Alright, so this value is 0.13 inches. So I don't like how inaccurate that is. Hold on. Is that accurate? Yeah, it does. It's a solid is a definitely a solid word. Solid, 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 solid. What is this measurement? What the heck? I'm just gonna go with 3.3 millimeters, I guess. That's such a weird measurement. Alright, let's make sure this is collinear here so I don't have to worry about that. I don't have a micrometer with me, so I can't really do... That would be a lot easier than some of these. 0.05 inches? .27. What the heck is that number? Is that number? I'm just gonna say it's 0.0. Okay, I guess that's... Yeah, I'm just gonna say 1.55 millimeters. .5 millimeters. Good enough. Collinear there. And that measurement, so this measurement we're gonna grab. Oh, why did I exit sketch? Our dimension, we're gonna grab this measurement. Wait, 1, 2, something. So that's 3 millimeters. I'm just gonna go 3 millimeters. That's, hold on. You know what? That's actually probably pretty accurate. I hate that that's accurate. God damn it. Yeah, I've just been complaining about the quality of this manufacturing. So all right, so this measurement is, the next measurement is 0.235, just over 0.235. So let's grab this. What is that in millimeters? 6 millimeters. All right. So I'll make that like that. Oh, nope, wrong. There, so let's pattern this down. So what we're gonna do, linear sketch pattern. We're gonna be doing in the y-axis, so, oh, nope, oh, whoops. Yeah, the mistake I made there was I clicked, instead of, I didn't click into the entities to pattern before I started clicking on stuff. So if you click on stuff before you hit entities to pattern, it will put them in the X directions. We want it to go the other way. And what is it? What point is it using to reference? I believe it's this. Okay. That's an easy measurement to get. I mean, honestly, I can just grab from there to there. That's going to be a whole lot easier. So let's grab that. All right, let's grab this. Let's get this measurement. .32 or 0.33. So 0.33 inches is That's 33 inches. 0.33 inches is 8 millimeters, or 8.3 millimeters. Is it slightly... Oh, that's kind of accurate, actually. So we're going to need to pattern this 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 times. One, 2, 3. Oh. Alright, so we got 3, 4, 5, 6, 7, 8, 9. I think that spacing's a little off. Huh. I do. No. Why did I do that? I could have just hit the dimension wide spacing. Okay, let's... Yes, thank you so much for stopping by, Dev. Have a good night. If it is night where you are, I don't know if it's... Alright, so now we dimensioned Y spacing, so that's quick and easy. We can just edit that value whenever we need to, and we'll start putting this down there. So this goes up to that. Oh, hold on. Just realized there's something I can do. Do that. That, make this equal. Wow, that's kind of close. Perfect. And this will just be extruded all the way down, so we'll do up to surface. Down here. Yeah, so this is pretty much like what the front looks like. These aren't like, these are a little curved, so it's not completely accurate, but... And then there's... Let's see. So basically 4.4 3/16. So the whole cutout starts 4 3/16. We'll put a center line. And then we'll put another line over here. And this measurement is 5 inches. Easy. Now this value, these values don't really need to be accurate because... Alright, let's do that. Now we're gonna need to convert we're going to start converting where these holes start, or where these holes are. So there's 8 cutouts. The bottom one does not have a cutout. It's, oh, am I seriously going to have to go through each one individually? Hold on. You're kidding me. Come on, there we go. Alright, Bert. Alright, so these are where the cutouts are. Let's trim those off. And each cut is going to be 0.14 inches. So we'll take your point, yeah, 0.1, really? 0.14? Oh, okay. Seems a little high. So we're just gonna take the offset tool. Oh, dang it, dang it. All right. And we offset reverse direction, cap ends, lines. Now we have our cutouts, so now we're gonna do extruded cut. To next. Yeah, so this is pretty much the front panel. And you can kind of see just how bad it is. Like, that's the only airflow into it. So we're just gonna be making something we can 3D print that will serve as the front panel. So, anyways, I have not had dinner. It is currently 11 p.m. I have not had dinner. And yeah, so I'm gonna go make some food. I'll try to be on tomorrow. But yeah, I should be on tomorrow. I'll try to be on tomorrow for at least a little bit. So yeah, if you enjoyed, feel free to stop by again. Thank you so much, and we'll just be continuing this tomorrow. Thank you for stopping by. And have a good one. Hope to see you again.